supported beam, we have a pin here at A, a roller here at B. This beam is of length L, which is 7 meters, and we have this uniformly distributed load across the entire span between A and B, and that load is 12 newtons per meter. So every meter we have 12 newtons of force coming down. So just like with any other shear diagram or shear moment diagram problem, the very first thing you always want to do is draw the free body diagram. So I'm going to redraw that beam here. Here is point A, here is point B. We know that the pin at point A supports two different reactions, one vertically and one horizontal. So there's our horizontal reaction. I'm going to call this AY, and I'm going to call this AX. So that's a horizontal reaction. And here at B, we only have a roller, so we know that it's only a vertical reaction, which I'll just call BY. Now, the very first thing we can do is actually look at this AX reaction and notice that there is no load going in the horizontal direction or the x-axis. So AX we can naturally see is 0. So the next thing I want to do is I want to go ahead and draw that distributed load in, which is our W load. And that is this uniformly distributed load of 12 newtons per meter. And to make this problem a little easier, I'm actually going to take this distributed load and resolve it in a point load. And we can do that when we're finding reactions, because we can use the single point load in the middle that represents W, or this 12 newton per meter, to figure out what AY and BY is. So we know that we can figure out what P is by taking W and multiplying it by L. So W we know is 12 newtons per meter and L is 7 meters. And if we do the math, that resolves to 84 newtons. Now do note that when you draw your shear and moment diagram, do not use this P load in the middle band. We're only doing this just so we can figure out what the reactions are. We're going to have to draw the shear and moment diagram based on the actual loading and actual reaction. So this actual W load and the actual AY and BY reactions. So in order to figure out what these reactions are, I can actually do the sum of moments at point A. So if I do sum of moments at point A and I say that is positive, then we have this positive BY, well, this needs to equal 0, right? So we have BY times its distance from A, which is 7 meters, and then this concentrated load P minus 84 Newton times 3.5 meters, right? Halfway between point A and point B, and that should be equal to 0. And if we simply do the math, we find that BY is equal to 42 newtons. And then we can do the sum of forces in the Y direction. So I'm going to say that is positive. That also needs to equal 0, right? So we have this positive AY going up, this reaction here, and we just figured out what BY is, so that is plus 42 newtons. And then we have this minus P, right? This minus 84 newtons, and that's because it's going down. That needs to equal 0. And again, if you do the math, we find that AY is also equal to 42 newtons. And that makes sense, right? Because this distributed load is uniformly distributed across the entire span, so our reactions should be the same, 42 and 40.